Air conditioning on this 2019 Hyundai Tucson. So this was front end collision, so it got the new condenser, but it also got a new pipe. Actually got two new pipes. It got the liquid line and the vapor discharge off of the compressor, because these got smashed. Now this liquid line on the suction line got replaced because of the damaged liquid line. And let's look at this right here. So the damage was slightly bent lines, but they're bent, but it's not horrible. I'm going to cut them off. So what I'm going to do is, on my Toyota Prius, I have a rear air conditioning from like a Toyota Sienna van. So say this is not a Sienna van, but they have the large air conditioning HVAC box right in the rear corner panel. And I got one of those from a body shop where it was damaged and it just broke off the plastic foot and it broke the case, like a little 50-cent hole. I can make that up with epoxy and plastic, and I could fix that and make it like brand new again. That's a $1,200 unit case assembly all by itself. And because my 2012 Toyota Prius does not have an internal heat exchanger, I could grab from another vehicle like this, and I could cut and I could braze my own pipes, and I can make up on my own fittings. I already have a high pressure transducer in here, and on the other line I think there's another transducer for high pressure, and I can use it to vary my fan at variable speeds. The Prius already has some speed control, but I want to tighten up the specifications for keeping the head pressure over the expansion valve to control it better, especially in cold weather, because I use air conditioning in cold weather. So something like this, I'll take something like this and I'll make my own custom fittings to fit into my Prius, but then I'm going to modify the condenser. So on my Toyota Prius, I will get something. Remember the last video, a couple days ago, I made on another, I think it was a van or an SUV, where they had a shorter, smaller condenser, and because it wasn't such a large SUV or van, and they made it shorter, they had to make it fatter, and it had dual air conditioning on it. So I will upgrade and modify my factory stock Denso condenser from what's original in the Prius up to the one that's in one of the SUVs or vans. Now the one that was in the SUV or van did not have the receiver dryer in it, built in like this. So it's just a condenser. So then what I'll do is I'll get a Toyota Sienna receiver dryer from one of the older year models. You guys who are familiar with air conditioning know that the Sienna had a slightly narrower receiver dryer that was about this big and round, but instead of being like 8 inches tall, it was like 12 or 13 inches tall. It was tall and narrow. So I'll upgrade my Prius to like a tall, thin, narrow receiver dryer off a Sienna that was built for dual air conditioning. I'll put in the rear air conditioning in the Sienna, out of a Sienna into the Toyota Prius in the rear quarter panel, and modify my system like that. So I'll have the heavier duty condenser, and I can play with the thermistors and the controls on temperature sensors with either rheostats or switching out. I could fool the system basically. And I've done this before. As long as the humidity is not high, I could get dash temperatures coming out at 27 degrees, 24 degrees for a certain amount of time until frost builds up, and then you got to cut it back, and you could cut it in and cut it out. So you get more load. And I'll have two evaporators in the system. Roughly I'll have like 3 tons or 4 tons of evaporator for a small Prius that I could turn the rear system on and off at will. The one other thing I want to get is a plate heat exchanger for a glycol loop, so I could custom make my driver's seat with a glycol loop system in the driver's seat, pumping chilled glycol through my back and under my seat inside my chair on the driver's side. So on really hot days, I could have like 40 degree, 50 degree temperature seat, constantly wicking away temperature from my body, so I'm not in a hot, sweaty seat. That's my end goal. So this is one. I got the Sienna. I got a couple of them actually. Rear evaporator HVAC housings. I'm gonna get a couple of these and see which ones. This I think I could get to fit in my Prius, and then I'll find that upgraded Denso condenser from one of the SUVs or vans to fit my Prius, and I will have to modify some sheet metals and brackets and custom make all my own fittings, but that will be all in a future video. All right guys, I'll see ya. Oh, back to this one. Brand new pieces everywhere, so I'm not just going to fill it up right now. I'm going to hit it with nitrogen. As you can see, I hit it with nitrogen already, and it's not letting nitrogen. You have about almost exactly 100 psi differential. So there's hard shut off expansion valves, and there's a difference. You have a lot of you guys got to study this. I'm not going to explain it in detail right now, but they like to leave a differential in pressure from your high side to a low side. Some manufacturers, some things, that's usually some, I'm not going to say all, and I'm not going to say everyone. There's kind of rules of thumb, and in this case it's exactly 100 psi. I'm pumping in high side nitrogen right from the high side nitrogen tank, and it's only down the high side. I pump this up with 164 psi. It cannot go backwards through the compressor, and because of the spring action and the diaphragm action, the way the expansion valve is, it keeps 100 psi differential pressure from the low side to the high side. So it allowed nitrogen to freely flow until there was 100 psi difference between the low side and the high side, and then the pintle went all the way, drove all the way down, and it stopped the flow. And this is the evidence right here. Here's 160, basically we're 165, 164. So you have 100 psi difference between the high side and the low side because the expansion valve is stopping any more dry nitrogen from flowing through the expansion valve to even get to the low side. You must understand your differential. All right, I'll see you guys later.